Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My course is going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam exam and other exams related to physics. My courses are absolutely free of charges, so anyone can watch and that will help the students to crack their examinations related to physics. Okay, so also I would like to thank you everyone who subscribed my channel, and also I would request the people who haven't subscribed my channel yet, please subscribe my channel. Okay, so this is the mathematical physics lecture number 5 which we are going to discuss today. Okay, so here we are going to discuss green theorem, Stokes theorem, divergence theorem, and and gradients, the fundamental theorem for gradients, and will solve questions related to that. And those questions are from IIT-Jam, Jest, and CSIR net. Okay, so I'm going to start now. Okay guys, I'm going to start. So first, so there are some property which I'm going to write down. So this is the first one is, we say, fundamental theorem, fundamental theorem, fundamental theorem for gradient, for gradients. Okay, fundamental theorem for gradients, and this is integration a to b gradient of phi. Phi is scalar quantity. Okay, so phi is scalar function. Okay, so gradient phi dot dr. Okay, dr. Okay, gradient phi dot dr. So this is going to be equal to integration a to b d phi, or we can write phi b minus phi a. Okay, so this is the fundamental theorem for gradients. Okay, there is a second property of Laplacian. Okay, so this is we'll write, this is del square a, or Laplace square a. The value of this is gradient of divergence of a. Okay, last time the class was I had to disconnect the class because of technical error. I apologize for that, guys. Okay, so this is okay, and then curl of a. Okay, so this is the one. So Laplace square a is gradient of divergence of a minus curl of a. Okay, so this is the second property, and the property number third is okay, property number third, this is this is green theorem. Okay, green theorem, green theorem. I will solve questions related to it, then it will be more clearer to you. Okay guys, so this is green theorem. What green theorem says? It says line integration phi dx plus psi dy. If there is any function, if there is any function like this psi dx or phi dx plus psi dx in this form. Okay, so we can for making it easy for integration, so this value is double integration del psi over del x minus del. Okay, this is going to be del psi over del x minus del phi over del x, okay, into dx dy. So this is the green function where phi and psi are continuous in x and y, okay, are continuous function in x and y. Okay, so this is the green theorem, statement of green theorem. Okay, so this is the one. Okay, very important, guys. So we can by this theorem we can solve a very complicated integration easily, okay, using this green theorem. Okay, okay, so next, number 4, this is Stokes theorem. Stokes theorem. Okay, Stokes theorem. Okay, so Stokes theorem is used if we want to convert line integration into surface integration. Okay, or similarly if we want to convert surface integration into line. Okay, so we use Stokes theorem, guys. Okay, so I'll write this statement now. So this is line integration around any curve A dot dl is going to be equal to surface integration, okay, curl of A ds. Okay, so this is the Stokes theorem. Okay, so where A is the vector. Okay, so we can easily convert line integration into surface, and it makes very easy to solve the integration. Very complicated integration we can easily solve by using Stokes theorem, guys. Okay, number 5, this is Gauss's divergence theorem. Gauss's divergence theorem. Gauss's divergence theorem. Gauss's divergence theorem. So it is, we can convert any surface integration into volume integration. Okay, so surface integration A dot ds A dot ds is going to be equal to volume integration divergence of A d tau or dv. Okay, this is volume element. Okay, dv. Okay, so these are the theorem. Okay, now we will solve questions regarding this. Okay, okay. Okay, guys, so we are solving the first question. I'm going to solve questions which are asked in GATE, NET, IIT-Jam. Okay, regarding which are related to these theorems. Okay, so this is question number 1, and this we need to find line integration, that is xy plus y square dx plus y, this is x square, guys. Okay, this is x square, not xy, x square. And this is y plus sin x, y plus sin x dy. Okay, and we have been given the curve, that is rectangular curve. Okay, this one, this is origin 0 0 0 comma 0, and this is pi comma 0, and this is pi comma 1, and this is 0 comma 1. Okay, this, and this is y axis, this is x axis, this is given, and we need to integrate this, find the integral of this. We have to find the integral of this expression. Okay, so we can, it would be very tough to solve this question. Okay, if we solve directly. Okay, but if we use a Green theorem here, this question is going to be very easy. Okay, so I'll write this statement of Green theorem. We know that is integration, which I have already mentioned earlier. Okay, so this is going to be integration phi dx plus psi dy is going to be equal to double integration del psi over del x minus del phi over del y dx dy. Okay, so here the value of psi is this one, psi is y plus sin x, and phi is x square plus, okay, so this one is I have done mistake here. So this is x square minus cos hyperbolic y, cos hyperbolic y. Okay, this is the question, and the value of phi is this one, phi is x square minus cos hyperbolic y, and the value of psi is y plus sin x. Okay, I hope guys you understood it. Now I will apply the Green theorem. So it is going to be, we can say the value of this is I. Okay, let's say this is I. So I is going to be, we can say the integration of this is I. Okay, so this I is going to be equal to integration del over del x into psi. Value of psi is y plus sin x plus del over del y x square minus cos hyperbolic y. Okay, into dx dy. So we have used this Green theorem. Okay, this is minus, guys, sorry, this is minus. Okay, so now this value is going to be I equal to, and here we put the integration value as well. So this is the curve which is given, right? So it is going to be 0 to pi and 0 to 1. Okay, 0 to pi and 0 to 1. Okay, so we'll solve it. So differentiating this function, it is going to be sin cos x. Okay, so integration 0 to 1 integration 0 to pi cos x, because the differentiation of y is partially differentiated is going to be 0. So if you differentiate sin x, this is going to be cos x. Similarly, here minus this. So x square differentiation is going to be 0, it's constant. I will take it as a constant. So this is going to be sine hyperbolic y. Okay, so this is minus sine hyperbolic y, and this is dx dy. Okay, then value of I is going to be 0 to 1, 0 to pi. We differentiate cos x minus sine hyperbolic y dx first, and then we'll take dy like this. Okay, so this is going to be I equal to 0 to 1. We'll integrate it, sorry. So we'll take dx first. Okay, so integration of cos x is going to be sin x minus integration of sine hyperbolic y is going to be cos hyperbolic y. Okay, and the limit is going to be 0 to pi, right, dx. Okay, so value of I is going to be we'll solve it. So 0 to 1, this is going to be we'll put the value. Sine pi is 0, sine 0 is 0. Okay, so it is going to be cos hyperbolic. Just let me check. So this is the plus, guys. Okay, this one cos sine cos hyperbolic y. This is minus minus plus. Okay, so this minus minus will be plus. Okay, this is plus, this is plus, because here minus and minus is going to be plus. Okay, okay, so now this value is 0 plus cos hyperbolic y. Okay, hyperbolic pi. Okay, so this will put the value, and cos, just let me check. There is some internet issue. Just give me 1 minute. I think there is an internet issue. Okay. I think it's fine. Okay, here we have taken a limit, right? So limit is going to be this one. So here we are going to take this 0 to 1 first. And this is 0 to pi. Okay. Similarly, here is going to be 0 to pi, 0 to pi. This is going to be 0 to 1. Okay, and 0 to 1. This is 0 to pi, and this is 0 to 1. Okay, this one 0 to 1. Well, 0 to 1, and I will solve it. So it is going to be 0 to 1. Okay, it is going to be cos hyperbolic 1 minus 1. Okay, we'll put the value. So it is going to like this, 1 minus 1, and now Now what we are going to do is here, this is going to be I equal to integration, I equal to integration 0 to 1, 0 to pi. This is cos hyperbolic 1 minus one dy. Okay, it's cos hyperbolic 1, guys. I is going to be this constant, right? So cos hyperbolic 1 y minus y cos hyperbolic 1 y minus y 0 to pi. Okay, so we'll put the value. So it is going to be pi cos hyperbolic 1, we'll put this value, and pi. Okay, so I is going to be equal to, we'll take pi as common, so cos hyperbolic 1 minus 1. Okay, so this is the answer. Okay, we have used Green theorem. Next question we are going to solve. Okay, this is Green theorem. Okay, question number 2, and this is a vector field F, a vector field F is given, that is sin y I cap plus x into 1 plus cos y j cap, cos y j cap. Okay, uh, okay, so now F is given, and evaluate evaluate the line integral, the line line integral. Okay, that is F dot dr. Okay, F is given. Okay, F dot dr, evaluate line integral F dot dr, where C is the circular path, C is the circular path, given by x square plus y square equal to a square. Okay, so this is the given, a vector field is given. Okay, and we need to evaluate the line integral of F dot dr, where C is the circular path given by x square plus y square equal to a square, means this is a circle of radius a. Okay, this is a circle of radius a. So this is a circle, guys. Okay, my drawing is not good. Okay, so this is the A, that is radius is A, and this is the equation. Okay, this is given. So now we need to find out integration f dot dr. Let's say it's I. Okay, so we'll put the value. So it is f sine y I cap plus x into 1 plus cos y j cap. Okay, into dot dr. Okay, so we need to find out this, and we know dr is dx I cap plus dy j cap plus dz k cap. Okay, this is the one. Okay, so this is the one. So now we'll use green theorem to solve it. Okay, so we can write is integration f dot dr integration f dot dr is going to be, you can write it like this, sin y after putting the value. So this is going to be sin y dx plus, okay, sin y dx plus x into 1 plus cos x, 1 plus cos x dy. Okay, this one. Okay, thank you, Swapnil. Okay, so just checking it. Well, okay, so we'll use green theorem. We know that is in the line integration, that is phi dx plus psi dy, that is going to be double integration del psi over del x minus del phi over del y. Okay, dx dy. Okay, psi. Okay, this is the, so we'll apply this. So that the value is f dot integration f dot dr is this I. So we'll write is double integration. Okay, so it is going to be, we'll put the value. Okay, here psi is phi is the sin y, and psi is this, but we'll write it completely. Okay, so this is going to be del over del x. We'll put the value of psi. Psi is this one, x into 1 plus cos y, x into 1 plus cos y minus del over del y. This is sin x, because the value of phi is this sin y. Okay, dx dy. Okay, so I is going to be equal to, we'll put the value, double integration So this is going to be x sine y. Cos y is x sine y. Okay. Minus, this is, let me just check this one. Okay, so this is, guys, here, this x is not here, okay, just 1 plus cos y, 1 plus cos y, okay, that's why there is some issue. So this is 1 plus x cos y, so it is going to be sine, this is, there is a x, guys, x and x, okay. So we'll differentiate it. Here we have done some mistake in differentiation, so this is going to be 1 plus the differentiation of this is going to be, this is sine y, okay, okay, 1 plus sine y, this is x, there is I think question is wrong, so this is x plus cos y actually, that's why there's a mistake, so this is x plus cos y. Yeah, this one is correct actually. This is x. Question is correct, guys. There is some mistake from our side. Okay, so this is going to be 1 plus sine y, okay, because we are differentiating with respect to x, okay. We have done mistake here in differentiation, okay. So minus, this is going to be sine y is cos y, okay, x plus sine y. Cos y. Let me just check, guys. I think there is some issue in question. So I vector field, this is given, and evaluate the line integral of this where c is the path given, okay. Sine y cos y, this is cos y, and this is sine y, okay, cos y and sine y. Yes, there's a mistake in question, that's why we're not able to solve it, okay. So this is sine y, there is some mistake, just give me 1 minute, guys, I'm just checking it. What mistake is this? Yeah. Yes, there's a mistake in question. That's why I was not able to solve it. Okay, so I'll rectify the question and then we'll solve it. It's easy one. So in the question, this is, guys, this is sine y. Okay, x into, so this is 1 plus sine y. Okay, so this is sine y. This is sine y. Okay, now it's easy. This is sine sine y. Okay, so now it's easy. Sometimes there is mistake in questions as well. Okay, so this is 1 plus minus cos y. This is minus cos y, the integration. Okay, and this is minus and minus cos y. This is plus cos y dy dx. Okay, so this is going to be uh, this is double integration, cos y get cancelled. It's dx dy. Okay, this is surface integration, and we know this is a circle. Okay, and area of circle, this is the area of circle, that is pi a square. Okay, this is the answer, guys. So there's a mistake in question, and that's why. So the question is this one. Okay, this one, sine y I cap plus 1 plus sine y x into 1 plus sine y j cap. Okay, this is the one. So that's why there's a mistake. Okay, so now we are going to solve another questions. Okay, so this is a very important question I'm going to solve, which is asked in Jest 2013. Okay, so this is the question number 3rd. Okay, and this is asked in Jest 2013. Okay, I'm going to write the question now. The question is, the vector field, the vector field xz I cap plus yj cap plus yj cap. Okay, in cylindrical 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 polar coordinates, cylindrical the vector field x z I cap plus y j cap in cylindrical polar coordinates is. Okay, so we have been given vector field in Cartesian coordinates and we need to convert it into cylindrical coordinates. That is the question, and this is asked in Jest 2013, and options are given. Option number A, rho z cos square phi plus sin square phi tp cap, that is rho cap, okay, p rho cap plus p sin phi cos phi into 1 minus z e phi cap, that is phi cap, okay. Option B is rho z cos square phi plus sin square phi e rho cap plus rho sin phi cos phi 1 plus z e phi cap, okay. Next, option C is rho z sin square phi plus cos square phi e cap rho, that is rho cap, okay. Rho sin phi cos phi 1 plus z e cap phi, okay. Option D is rho z sin square phi plus cos square phi e rho cap plus rho sin phi cos phi 1 minus z phi cap, that is e phi cap. It's phi cap, okay. So this is the question. So we need to convert. We have been given vector field in Cartesian coordinates, okay, and we need to find out this vector in cylindrical polar coordinates, okay. In cylindrical, we need to convert it into cylindrical polar coordinate, okay. So very good question, and it is asked in Jest 2013. Okay, so I'm going to solve now. So given vector is given vector is, that is x z I cap plus y j cap, okay. Okay, x z I cap plus y j cap. This is the vector in Cartesian coordinate, and we need to convert it into cylindrical. So what will be the vector in cylindrical coordinate, okay. So we know in cylindrical coordinate system, in cylindrical coordinate system, we know x equal to rho cos phi y equal to rho sin phi, and z equal to rho, sorry, z equal to z, okay, z equal to z, okay, z equal to z, okay, I'm just checking, okay. So very easy, we can easily convert this vector into a cylindrical coordinate system, right? So there's a formula you need to remember, you need to note down, and this is I cap, j cap, and k cap. This is equal to, we'll take 3 by 3 vector, and this is 3030, and this is sine phi, cos phi, 0 0 0 1. Okay, if you know this, then you can easily find out, easily convert a Cartesian system into this vector into a cylindrical coordinate system. Okay, so this is the one, this is simple, ijk rho phi z, this is cos phi minus sin phi, then sin phi cos phi, 0 0, this is 1. Okay, so we'll solve this equation. So it is going to be I cap, j cap, k cap, it will remain as it is. Okay, okay, so this is going to be, so we'll solve it. Okay, this will we know matrix multiplication, right? This with this. Okay, so this is going to be cos phi rho cap, cos phi rho cap, minus sin phi phi cap, minus sin phi phi cap, plus 0. Similarly here, sin phi rho cap, sin phi rho cap. I hope guys you know the matrix multiplication, right? This row with this column, then this row with this column, then this row with this column. Okay, so this is sin phi plus this one, cos phi phi cap, cos phi phi cap, plus 0, and this is going to be this one, 0 0, plus z cap, 0 plus 0 plus z cap. Z cap. Okay, so this is going to be equal to, you can write this, cos phi rho cap minus sin phi phi cap, sin phi rho cap plus cos phi phi cap into z. Okay, this one. So in this implies we can easily find value of I cap is equal to cos phi rho cap minus sin phi phi cap, and value of j is sin phi rho cap minus cos phi phi cap. Okay, and and j cap equal to z, sorry, k cap equal to z. Okay, so this one, cos phi rho cap minus sin phi phi cap, and sin phi rho cap plus cos phi z cap, this is plus. Okay, okay, well, so now we know the value of I, j, k, right? So we'll write the vector. The vector is x, z, I cap plus y, j cap, right? Y, j cap, y, j cap, okay. So we'll put the value here, simple. We know the value of x is rho cos phi, z is z, okay, and I cap we have already got here, cos phi rho cap. You just need to memorize this matrix, right? And then you can easily find out the value of ij, and after that you can easily find out, okay? So this is going to be I cap. I cap is cos phi rho cap, cos phi rho cap minus sin phi phi cap, sin phi cap, okay? Plus value of phi we know, this is rho sin phi, and this value is going to be this is simple, and this is going to be sin phi rho cap plus cos phi cap, which we have already here, sin phi rho cap, this one, okay? Now we'll this is the this is the this is the vector in cylindrical coordinate system. Now we'll arrange it and go to the right answer. So we are going to this is going to be rho z cos square phi rho cap, okay, minus rho z cos phi sin phi cap, okay. This is rho z, guys. I'm writing again because rho z, okay. Similarly, we'll multiply this one. This is going to be rho sin square phi rho cap plus rho sin phi cos phi cap, okay. So this value is going to be equal to, after arranging, rho z cos square phi plus rho sin square phi, okay, rho cap, this row and this row one together, okay, and phi rho, and the second is rho sin phi cos phi, okay, rho sin phi cos phi into 1 minus z. This is z, right? 1 minus z. This is phi cap. Okay, this is the answer, guys. Now we'll match the option. Which option is matching? So the option A is matching. See, rho z, this one, and this is nothing but rho cap, and this is nothing but phi cap, okay? So this one, rho z cos square phi plus sin square phi, e cap rho or rho cap plus rho sin phi cos phi 1 into 1 minus z, e cap e rho cap or phi cap, this one, rho z, okay. Here well, this is rho z, okay, z is here, okay. Here we have made some mistake, so this is z, okay, z cos, this one, okay. This is the answer, guys. Very good question. So you can easily, so what you need to do, you just need to because in cylindrical coordinate we know the value of x, y, z, and we need to find out value of I and j. We just need to put in the expression, and we'll get the expression in cylinder. We can convert it, that the vector, into cylindrical polar coordinate system. Okay, guys. Well, so this is the just question. Next question we are going to solve. So let me check this one. So next question we are going to solve. This is the question which is asked. This is the net question, guys. Okay, which is asked in CSIR net. So I'll write it for you. Question number 5, I believe. Question number 5. So is this question number 4? Let me just check. Or question number 4, I think. Yeah. Let me just check. This is question number 4. 4, guys, not 5. Question number 4, which is asked in CSIR net. CSIR net, December 2013. Okay, December 2013. Okay, very good question related to the topics which I have taught you so far. Okay. Okay, I'll write the question. If okay, if vector A is I cap YZ plus J cap XZ plus K cap XY this is the vector which is given, then the integral A dot dl, line integral A dot dl, where C is along the perimeter of a rectangular area bounded by x equal to 0, x equal to a, and y equal to 0, y equal to a. Sorry, y equal to b. Y equal to b is okay. Options are given. Option number A, 1 by 2 a cube plus b cube, Option B is pi ab square plus a square b, square plus a square b. Option C is pi a cube plus b cube, pi a cube plus b cube, and option D is 0. Okay, so this is the question, guys, which is asked in CSIR net December 2013. A very good question. A is given. Okay, then we need to find out the integration of A dot dl, line integration of A dot dl, where C is the perimeter of rectangular, and condition is given x equal to 0, y equal to this. Okay, x equal to 0 and x equal to A, this one. Okay, so we'll solve it now. Okay, so we'll find out integration directly. A dot dl is equal to, value of A is yz I cap plus xz j cap plus xy k cap dot dl we know, that is dx I cap plus dy j cap plus dz k cap, right? Since value of dl equal to dx I cap plus dy j cap plus dz k cap. Okay, well, so now this is y, guys. Okay, yz. Okay, so now if we want to solve like this, it is going to be very tough, right? So but we can easily solve it by using Stokes theorem. Okay, so here we can convert this line integral into surface integration, right? Stokes theorem we know, that is integration A dot dl, that is going to be, this is line integration. Okay, this is going to be surface integration curl of A, Stokes theorem, guys. Okay, Stokes theorem. This is curl of A ds, right? Okay, guys, so this by this we can easily solve it. This is Stokes theorem. Here we'll use it. Okay, so this is the A dot dl, and now we'll find curl of A. Curl of A. Okay, this is going to be I cap j cap k cap del over del x, del over del y, and del over del z. Okay, and value of A is yz, zx, and xy, which is given, right? Because A is given, yz, xz, or xy. Okay, zx or xz, this is same thing. Okay, so this one, now we'll solve it. So it is going to be, we'll take I as common, this one, this line will get connected, this is this, right? So this is going to be del over del x, xy is going to be y. Similarly, this is minus y minus j cap, this one, this one, this one. So this is going to be first this one, right? Y. So this is going to be x. Okay, this is x. X minus x, this is j cap. So this is y minus y, and this is plus k cap. We'll solve this one. So this is going to be z minus z. Okay, okay, here this is the mod one like this. Okay, this is straight line actually, this one. Okay, so this is going to be 0. Okay, so curl of A is 0, so that implies integration We don't see because of this theorem how easy this question is, right? And this is asked in December 2013 in CSIR net. Okay, so this implies integration A dot dl is going to be 0 because of curl theorem, because curl of A is 0. So which option is the correct option for this? So integral of this is going to be 0. So option number D is the correct one. Okay, guys. So next question we are going to solve. Question number 5. This question is IIT-Jam question, guys. We are going to solve. Asked in IIT-Jam. Okay. The question is, question number 5. Okay. The line integral A to B f dot dl, where f is x upon root x square plus y square I cap plus y upon root x square plus x square plus y square j cap along the semicircular path, semicircular path as shown in the figure below, is okay. This is the question, guys, which is asked in IIT-Jam 2011. Okay, IIT-Jam 2011. Okay, so it is asked in IIT-Jam 2011. Okay, guys. So figure is given. This is x direction, this is y direction, and this is the semicircle. Okay, this is semicircle. This is -1 0 and this is 1 comma 0. Obviously it is C. The radius of this semicircular circle is circle, guys. Okay, it's 1, clearly seen in the figure, and options are given. Option number A, that is -2, option B, that is 0, option C, that is 2, and option D, that is 4. Okay, so this is the question. We need to find out the line integral. This is the question which is asked in IIT-Jam 2011. Okay, the line integral we need to find out f dot dl, where value of f is given. Okay, f is given, and along this semicircular path as shown in the figure. Okay, so I'm going to solve it. Okay, So we know because there is a circle of semicircle of radius a, right? So given, it means that implies x square. We know the equation of circle, right? X square plus y square equal to 1. Okay, so that implies will what we are going to do is we are going to differentiate it with respect to x and y. So this is going to be 2x dx is going to be equal to minus 2y dy equal to 0. Integration of the differentiation of 1 is 0, that is constant. So it is going to be 2x dx equal to 2y dy. Okay, that implies x dx equal to y dy. Okay, this is equation number 1. Okay, because the semicircle is given path. Okay, this one. So radius is obviously it is 1. Okay. Okay. So now we'll find f dot dl, because we need to find integration f dot dl, right? This one. So first we will find f dot dl, then we'll put the value. Okay. So f dot dl is going to be, value of f is x upon root x square plus y square plus y upon root x square plus y square. This is given, and dot dl. dl is dx dy, right? Okay, f dot dl is this. So now we will write f dot dl equal to f dot dl. Since we know dl is dx I cap plus dy j cap. Okay, and f is also already given. This f, the value of vector f is this. Okay, we have solved here, right? Okay, it's okay. Okay, so this one, and f is also, we know f is also given, x upon vector f is also given, right? F upon root x square plus y square I cap plus y upon root x square plus y square j cap. So we can easily find out f dot dl. F dot dl value is going to be this. Okay, so this is going to be, here we have written this one, and okay, so now we can write x dx dy. Okay, so it's going to be x dx and y dy. How? Because we will take dot product of this, right? And we know how to do dot product, right? This is going to be I cap I is 1, x, this one x dx y. And now we know, now from this equation, equation number 1, it's it's clearly seen that x dx equal to y dy. Okay, so here we can write x dx equal to minus y dy. Okay, minus, this is plus. Okay, this is minus, it will go in right hand side, right? So here we'll write the value f dot dl, that is minus y dy from equation 1 root x square plus y square plus y dy root x square plus y square. Okay, obviously, so these are equal means it is going to be 0. Since f dot dl is 0, right? So implies integration f dot dl, this one f dot dl a to b f dot dl is going to, because this value is 0, it's going to be 0. So 0 is the answer. So which option is matching? Option number B. Okay, option number B is the correct one. So very simple. What we have done is we have been given a semicircular contour, that is right, a semicircular curve, and we know the equation of circle, right, and the area is the radius is 1. So from there we have got this condition, x dx equal to minus y dy, and by that we have find f dot dl, and we put the value of instead of in place of x dx we have written y dy from equation 1, and that is giving value 0, and that's why the integration of f dot dl is 0. Okay, this is the answer. So option number B is the correct option. Okay. Okay, guys. So we are going to solve next question. Next is next question is also asked in IIT-Jam exam. Okay, it's also a good question. Question number 6. Asked in IIT IIT-Jam 2004 2014. Okay, this is the IIT-Jam 2014 question, guys. It is asked in IIT-Jam 2014. Okay, I'll write the question first. Question is, the line integral a dot dl of a vector field a which is function of xy is given 1 upon r square minus yi cap plus x j cap, where x r square equal to x square plus y square okay, is is taken around a square, around a square. See figure. I'll draw the figure as well. Okay. See figure of side of unit length of side of unit length side of unit length and centered at x0 comma y0 with x0 greater equal mod x0 greater equal to 1 by 2 and mod y0 greater equal to 1 by 2 if the value of if the value of integral is L, if the value of integral is L then options are given. Option number A, L is depends on xy. L depends on x0 comma y0 y0. Okay, x0 comma y0. And B option is L independent of L is independent L is independent of x0 comma y0 and its value is -1. Option C, L is independent of x comma y0 and its value is 0. Option D is L is independent of x0 comma y0, that is x0 comma y0, and its value is 2. Okay, this is the option, and figure is given like this one. This is x, this is y, and this is the curve, and this is x0 comma y0. Okay, this is given. This is x0 comma y0. Okay. Okay. So this is also very easy question. We can easily solve it by using Stokes theorem. Okay. So we need to find out value of that is integral value L, right? So L A dot dl, right? We need to find This is, I'll draw again. Okay, this is the square. Okay, and this is the point x naught comma y naught. Okay, okay. So we have to find out the value of L, that is A dot dl, right? And we know of A ds. So first we will find out curl of A. Okay, so curl of A is going to be I cap, j cap, and k cap, and values are, this is del over del x, del over del y, and del over del z. Okay, and this is the value, this is y upon x square plus y square, x square plus y square, and this is x upon x square plus y square, and this is 0. Okay, because the value of A is this. Okay, 1 upon, and then r square equal to x square plus y square, right? So we have made this, right? And we have, okay, just let me check. Okay, so and if we solve it, we can find that del cross A is, this value is 0, right? So it means the value of L, that is integration A dot dl, is 0. So which option is correct here? So which option is going to be there? This is obviously this value is not depending upon x0 and y0, right? So option B is correct. L is independent of x0, y0. Okay, and its value, oh wait, this option C is correct. L is independent of x0, y0, and its value is 0. So option C is the correct option. Okay, guys, I'm going to stop here, and thank you so much for watching the video, and I would request you, please subscribe my channel, who haven't not subscribed my channel yet, and watch my free lectures. My lectures are very important for different competitive examinations related to physics. Okay, thank you guys, bye now.